Greetings and welcome to Blossoming Brains. If you don't mind, just take a moment and imagine this. It's midnight and you have a big exam or an important certification test first thing tomorrow morning. You've been studying for hours. Your highlighters are running dry, your coffee cup is empty, but you tell yourself, just one more hour. I can sleep when it's over. Sound familiar? Or maybe you've had this experience. You've been wrestling with a problem for days, a tricky work situation or a creative block, a conflict that you just can't figure out how to resolve. You go to bed feeling stuck, and then, almost like magic, you wake up the next morning with the answer, clear as day, right there, waiting for you. Both of these experiences are telling you the same thing. And today we're going to unpack exactly what that is. At Blossoming Brains, we use scientific research to support lifelong learning. And I'm your host, Dr. Vicki Draeger. I've spent more than 30 years in education, from sitting cross-legged on the floor with preschoolers to standing at the front of graduate-level classrooms, to everything in between. And in all of those years, in all of those classrooms and with all of those learners, one of the most consistent and heartbreaking things I've witnessed is people working against their own brains without even knowing it. Today we're going to talk about one of the most powerful and most underestimated learning tools available to every single one of us, regardless of age, budget, or background. It doesn't cost a dime. It doesn't require an app or a subscription. In fact, you do it every single night, or at least you're supposed to. We're talking about sleep. Specifically, we're going to explore the fascinating neuroscience of how sleep consolidates learning. We'll look at what happens in your brain during different stages of sleep, why sleep deprivation is essentially the enemy of learning, and how you can use what science tells us to become a more effective learner at any age. And I promise, no jargon without an explanation, and no concept without a real-life connection. So, get comfortable, grab a tea or coffee, and let's get into it. I want to start with the bad news because I think it's important to understand what we're working against. The enemy here is sleep deprivation. When you're sleep deprived, your brain's ability to learn new things can drop by as much as 40%. That's not a small dip. That's nearly cutting your learning capacity in half. Dr. Matthew Walker is a neuroscientist at the University of California in Berkeley, and he's the author of a book called Why We Sleep. Dr. Matthews has spent his career documenting just how catastrophic sleep deprivation is for the learning brain. When I say sleep deprivation, I don't just mean pulling an all-nighter. I mean consistently getting less than the recommended amount of sleep. For most adults, that's 7 to 9 hours a night. For our teenagers, it's 8 to 10 hours. For school-aged children, it's 9 to 11 hours. And for our preschoolers, they need 10 to 13 hours. Yet, study after study shows that most of us, and most of our children, particularly teens, are falling significantly short of those numbers. So why does sleep deprivation hurt learning so much? To understand that, I want to once again introduce you to that very important part of your brain, the hippocampus. You'll recall that the hippocampus is a small seahorse-shaped structure deep inside your brain, and it is your brain's primary memory recording center. Think of it as your brain's sticky notepad. When you learn something new, a name, a fact, a new skill, a piece of information from a lecture, your hippocampus is the first place that information lands. It holds it there temporarily, while the rest of your brain figures out what to do with it. Here's the thing about sticky notes, though. They can only hold so much. The hippocampus has a limited capacity. When you're sleep deprived, that sticky note pad gets full and stays full. There's no room for new information to stick. It's like trying to pour water into a glass that's already overflowing. The new information just spills right over the edge and is lost. Dr. Walker describes it beautifully. He says that sleep before learning helps prepare the brain for the initial formation of memories. Without that sleep, the hippocampus can't receive new information effectively. The inbox is full and nothing new can come in. So here's where it gets even more concerning. The problem with sleep deprivation isn't that you can't take in new information. It's also that the information you did manage to absorb during the day never gets properly processed. It stays fragile, temporary, and vulnerable. Like imagine you've just taken a photograph. You've captured the moment. But in the old days of film cameras, the photo had to be developed. It had to go through a chemical process in a darkroom before it became a real, lasting image. Without that development process, the image would fade and disappear. Sleep is the darkroom for your memories. Learning takes the photo. Sleep develops it. When Dr. Robert Stickgold of Harvard Medical School studied students who learned a new task and were then deprived of sleep for a single night, those students were less able to remember how to perform that task for up to 3 days afterward. 3 days! And here's the really sobering part. Even if those students caught up on sleep on subsequent nights, the brain was still less able to retain the information from the day before the all-nighter. That window of opportunity for consolidation had closed. This is why I always tell my students, whether they're 5 years old or 50, that the sleep they get after learning something is not optional. It's part of the learning process itself. As an undergraduate, I attended Washington University in St. Louis, Missouri. Local residents and students just call it WashU. This reputation stems from its elite status and rigorous academics and high selectivity and consistent ranking among the top national universities. So I wasn't coming from a fancy prep school, but from a large public high school. And let me tell you, the academics at Washington University were really tough. Many of my classmates would pull all-nighters before big exams. As my mom would tell you, I always needed and insisted on my sleep. In fact, her very words were, if that girl doesn't get her sleep, she's a real pain in the... Well, you get the idea. I would study until 10 and then lights out. I don't think I was any brighter, I'm sure I wasn't, than many of my classmates. I did far better on exams than those that had stayed up all night cramming. Some of them would fall asleep during the test. So if the waking brain is for acquiring new information, the sleeping brain is for consolidating it. And this is where things get truly fascinating. Memory consolidation is the process by which your brain takes those fragile, freshly formed memories and transforms them into stable, long-term ones. It's the difference between a sticky note that might fall off the fridge and a permanent entry in a well-organized filing cabinet. I like to think of the sleeping brain as an overnight librarian. Imagine a library, your brain, that's been open all day. People have been coming in and out, dropping off new books, rearranging things, leaving materials scattered on tables. At the end of the day, the library closes. The doors lock. And that's when the librarian really gets to work. She goes through every table, every cart, every pile of returned books. She decides what's important enough to shelve permanently, what needs to be cross-referenced with other materials, and what can be discarded. By morning, the library is organized, efficient, and ready to receive new information again. That librarian is your sleeping brain, and she works in shifts. Your brain doesn't just have one type of sleep. Throughout the night, you cycle through different stages of sleep in roughly 90-minute loops. These stages fall into two broad categories: non-rapid eye movement sleep, NREM, or rapid eye movement sleep, which we all have heard about, or REM sleep. And each stage has a very specific job to do when it comes to memory. Let's talk about NREM sleep first, and specifically its deepest phase, which scientists call slow wave sleep or deep sleep. This is the stage where your body is most completely at rest. Your heart rate slows, your breathing becomes deep and rhythmic, your muscles relax. If someone tried to wake you up during slow wave sleep, you'd feel groggy and disoriented, what scientists call sleep inertia. Your body really does not want to be disturbed during NREM, this slow wave sleep. And for good reasons, because while your body is deeply still, your brain is engaged in one of its most important tasks, transferring memories from the hippocampus, that temporary sticky note pad, to the neocortex, which is the brain's vast, long-term storage system. Think of the neocortex as the permanent hard drive of your brain, the filing cabinet that holds everything you've ever truly learned. Here's how this transfer works, and I want to paint a picture for you because it's genuinely remarkable. During slow wave sleep, powerful electrical waves called slow oscillations sweep rhythmically through your brain like gentle ocean waves rolling across a shore. And nestled within those slow waves are two other critical types of brain activity: sleep spindles and sharp wave ripples. The sharp wave ripples originate in the hippocampus. They are rapid bursts of neural activity. Essentially, the hippocampus is replaying the memories of your day, not in real time, but at an accelerated pace, sometimes up to 20 times faster than the original experience. Your brain is essentially fast-forwarding through the highlights of your day, reviewing what happened, what you learned, and what mattered. The sleep spindles, which look like little bursts of electrical activity on a brain scan, almost like the spindle of a spinning wheel, act as the courier service in this operation. They help coordinate the transfer of those replayed memories from the hippocampus to the neocortex, where they'll be stored permanently. And here's something that I find particularly remarkable. This process doesn't just copy memories from one place to another, it also integrates them. The sleeping brain takes new information and weaves it into the existing fabric of what you already know. New vocabulary words get connected to words you already know. New historical facts get linked to the timeline of events you've already stored. New skills get associated with similar movements you've already mastered. Sleep doesn't just file new information away. It finds where it belongs in the larger story of everything you've ever learned. That sounds almost like a miracle. So this is the process that primarily benefits what scientists call declarative memory. And declarative memory is the memory of facts and events. The name of the capital city you studied, the formula you worked through in class, the details of the meeting you attended, all this gets strengthened and organized during sleep, slow wave sleep. And here's a fascinating detail that speaks directly to parents and teachers. Research has shown that sleep spindles are particularly active in children and adolescents, which may be one reason why young brains are so remarkably good at absorbing and retaining new information when they get enough sleep. Now let's talk about the other major player in our memory story, and that would be REM sleep. REM sleep, rapid eye movement sleep, is a stage where your eyes dart back and forth beneath your closed eyelids. Your brain activity during REM sleep looks remarkably similar to when you're fully awake. Your heart rate and breathing speed up. Your body, interestingly enough, is temporarily paralyzed. This is a protective mechanism that keeps you from physically acting out what's happening in your brain. REM sleep plays a particularly important role in what scientists call procedural memory, the memory of how to do things. Playing a musical instrument, riding a bike, typing without looking at the keyboard, executing a new dance move. These kinds of skills are refined and automated during REM sleep. Studies have shown that after a night of sleep, people perform better on procedural tasks without any additional practice. The brain is essentially rehearsing for you while you rest, smoothing out the rough edges, making the movements more fluid and automatic. So, if you're a music teacher, a sports coach, or a parent trying to help your child master a new skill, know this. The practice session is important, but the sleep that follows is when the real magic happens. But REM sleep has another remarkable function that I want to spend a little time on, because I think it speaks to something every learner experiences, and that's the phenomenon of insight. You know that feeling when you've been stuck on a problem, really stuck, and then suddenly, seemingly out of nowhere, the answer arrives. That aha moment, that's insight. And sleep, particularly REM sleep, is one of the most powerful facilitators of insight that we know of. Here's why. During REM sleep, the brain is doing something extraordinary. It's not just replaying individual memories, it's connecting them. It's taking new information and colliding it with your entire lifetime of experiences, looking for patterns, associations, and connections that weren't obvious before. It's like a creative brainstorming session happening entirely without your conscious awareness. There was a landmark study published in the journal Nature by Ulrich Wagner, and his colleagues demonstrated this beautifully. Participants were given a series of math problems to solve using two specific rules. What the participants didn't know was that there was a hidden shortcut, an elegant, simpler way to solve the problem that the researchers had embedded in the task. After an initial practice period, some participants were allowed to sleep, while others stayed awake for an equivalent amount of time. When they returned to the math problems, nearly 60% of the participants who had slept discovered the hidden shortcut on their own, compared to only 23% of those who had stayed awake. Sleep had done something that extra practice time had not. It had reorganized the information in a way that allowed the brain to see the problem differently and find the shortcut. So this is probably why sleeping on it, when we say, oh, I'm just going to sleep on it, it's not just a folk saying. It's a neurological reality. When you go to sleep with an unsolved problem, your brain continues working on it, making connections you couldn't make while you were awake and consciously focused on the task. The focused analytical mind sometimes gets in its own way. Sleep loosens those constraints and lets the brain roam more freely across its vast network of stored knowledge. Another study found that participants who took a 60-minute nap after reaching an impasse in a video game were twice as likely to solve the puzzle afterward compared to those who stayed awake during the same period. Twice as likely from a single nap. So the next time you're stuck, whether you're a student, a professional, a parent trying to solve a family challenge, which we all have at one time or another, give yourself permission to step away and sleep on it. Your brain will keep working even though you're not. Now I want to share one more important concept with you because I think it changes the way we think about sleep entirely. It's called synaptic homeostasis, and it was proposed by neuroscientists at the University of Wisconsin in Madison. I know synaptic homeostasis sounds like a mouthful, so let me break it down with an analogy. I'd like you to think about a garden. During the spring and summer, everything grows. New branches sprout, new leaves unfurl, new flowers bloom. It's beautiful and abundant. But if you never pruned that garden, it would eventually become overgrown. The plants would compete for resources. The weaker growth would crowd out the stronger. The garden would lose its shape and its purpose. So now imagine that your brain is that garden. During the day, as you learn and experience new things, your brain forms new connections between neurons, the cells that make up your nervous system. You may know that these connections are called synapses. A lot of us have heard that term. Every new piece of information you take in, every new skill you practice, every new conversation you have, all of it creates a strengthened synaptic connection. By the end of a full day of learning and living, your brain has a lot of new growth going on. So sleep is where the gardener comes in. During slow wave sleep, the brain engages in a process of smart pruning. It weakens and removes the synaptic connections that were less important, the trivial details, the redundant information, the mental clutter of the day. And simultaneously, it strengthens the connections that were important, the key information, the meaningful experience, the skills that are worth keeping. This pruning process does two critical things. First, it saves energy. A brain that's constantly growing new connections without ever pruning them would eventually exhaust itself. Second, and more importantly for learning, it clears space. By removing the clutter, sleep prepares the brain to learn again the next day. It resets the hippocampus, empties the sticky note pad, and gets the inbox ready for new messages. Sleep is the price we pay for brains that are plastic and able to keep learning new things. Without sleep, we would eventually reach a point where the brain simply couldn't form new memories. It would be too full, too cluttered, and too exhausted. This is why sleep isn't a passive state. It isn't wasted time. It's an active, essential, biological process of maintenance and optimization. And it is as much a part of learning as any lecture, any textbook, or any practice session. I want to ask your brain to do 3 small things that make a big difference. Follow this podcast, like this episode, and subscribe. When you follow, like, and subscribe, your app saves Blossoming Brains for you and reminds you when new episodes come out. Follow so you can find the podcast again. Like so the apps know this episode was valuable. Subscribe so your brain gets a gentle reminder to keep growing with us. So, one more time, for your beautiful, busy brain, follow the podcast, like this episode, and subscribe to Blossoming Brains wherever you're listening or watching. So when people say, I'm not going to sleep now, I'll have plenty of time to sleep when I'm dead, that is not a good thing to be saying. You need your sleep and you need it now. As someone who's taught learners from ages 3 to their mid-50s, I want to take a moment to talk about how sleep and memory interact across different stages of life, because the story changes as we age, and not always in the way that we'd hoped. For young children, sleep is absolutely foundational to learning. The brain of a preschooler or a kindergartner is developing at a breathtaking pace, forming new connections at a rate that will never be matched again in life. Sleep, including daytime naps, is when much of that development is consolidated. So when schools remove nap time, they are not doing their little kindergartners any kind of a service. Research has shown that children who nap after learning new words retain them significantly better than children who don't. This is one reason why nap time in early childhood education isn't just a break for tired teachers. It's a crucial part of the learning day. For school-age children and teenagers, the stakes are just as high. Studies have consistently shown that students who get adequate sleep perform better academically. They have better attention and focus, and they show stronger emotional regulation. One study found that students who received less than 6 hours of sleep showed a pronounced decline in academic performance. Early school start times, heavy homework loads, extracurricular activities, and the ever-present pull of screens and social media, our teenagers are among the most chronically sleep-deprived population in the country. For adults, the picture is equally important. Whether you're learning a new language, mastering a new software system, developing a new professional skill, or simply trying to stay sharp in a demanding job, sleep is your most powerful ally. Dr. Stickgold's research suggests that for every hour you're awake during the day, your brain needs approximately a half hour of sleep to process the information you've encountered. Think about that the next time you consider staying up late to squeeze in a little more studying. And for older adults, the conversation becomes particularly poignant. Beginning in our late 30s, the amount of slow-wave sleep we get each night begins to decline. Already in our late 30s. By the time we reach our 60s, we may have lost up to 70% of our deep sleep compared to our younger years. This decline is directly linked to the memory challenges that many older adults experience. The names that slip away, the details that become harder to hold on to. But here is the hopeful part of this story. Dr. Walker and other researchers are actively exploring ways to enhance deep sleep in older adults through targeted sound stimulation, temperature regulation, and other non-invasive approaches. The message is that sleep isn't a fixed, unchangeable variable. It's something we can work to improve, and improving it at any age can meaningfully improve our ability to learn and to remember. So, where does all of this leave us? What do we actually do with this information? I want to give you a clear, practical call to action, because that's what Blossoming Brains is all about. Taking the science and turning it into something you can use in your real life, starting today, to help make you a lifelong learner. First, reframe how you think about sleep. Stop treating it as downtime, laziness, or something you'll catch up on over the weekend. Sleep is an active, essential phase of the learning process. It is not separate from your education or your professional development. It is your education. It is your professional development. When you sleep, you are learning. Second, protect your sleep hours. For most adults, that means aiming for 7 to 9 hours per night. For teenagers in your household, it means 8 to 10 hours. For younger children, it means even more. This isn't a suggestion. Based on the science, these are the hours your brain needs to do its consolidation work. Cutting them short is cutting your learning short. Third, study and then sleep. If you have something important to learn for an exam, a certification, a new job, a creative project, do your studying and then get a full night of sleep as soon as possible afterward. The most critical window for memory consolidation is in the hours immediately following learning. Don't let that window close by staying up late. 4, embrace the strategic nap. A 20-minute nap can restore alertness and sharpen focus. A 90-minute nap is long enough to include both deep slow-wave sleep and REM sleep, giving your brain a full mini-cycle of consolidation. If you have a big learning day ahead, a nap beforehand can clear your hippocampus and prepare it to receive new information. If you've just had a big learning session, a nap afterward can help lock it in. 5th, create a sleep-friendly environment. Keep your bedroom cool, dark, and quiet. Avoid screens for at least an hour before bed. The blue light from phones and tablets suppresses melatonin, the hormone that signals your brain it's time to sleep. Establish a consistent bedtime and wake time, even on weekends, to keep your body's internal clock well regulated. And finally, if you're a parent, a teacher, an employer, anyone who influences the schedules of others, advocate for sleep. Push back against the culture that glorifies busyness and sleep deprivation as badges of honor. Talk to your children's schools about homework loads and start times. Model healthy sleep habits in your own home. Remind your students, your employees, your teammates, and yourself that rest is not the enemy of productivity. It is the foundation of it. The science is clear. Sleep is not a luxury. It's a biological necessity and a learning superpower. And the best news of all, it's available to every single one of us every single night. So now, thank you so much for spending this time with me today. I hope that the next time you lay your head on that pillow, you do so with a sense of purpose, knowing that your brain is about to do some of its most important work. If today's episode resonated with you, I'd love to hear about it. Do you have a story about a time when sleeping was a problem, or sleeping on a problem led to a breakthrough? Or maybe you've noticed a difference in your own learning when you prioritize sleep. Share it with us on our social media channels. You can find references to today's podcast at vickidraeger.com. Now, until next week, thank you for joining me on this episode of Blossoming Brains, and don't forget to keep learning, keep growing, and keep blossoming. Thank you.